Hi there. Go is a wonderful programming language, one of my favorites. It's full of capabilities and it makes you really productive. So I have designed this series of videos to take a feature walkthrough while we write a real-world application. But before we start, I would like to agree upon some rules of engagement. This is not the typical Go tutorial, so I'm not going to cover every bit of the Go syntax for these videos. Instead, what I'm going to do is to explain the bare minimum in order to understand the examples that we are writing. There is going to be some other content that is going to be released. There are going to be some articles and an online workshop. Feel free to use these materials together with these videos or separate it as it suits you better. If you're a newbie, and we all have been there, my recommendation is that you take a step further and type along with me to check that the code behaves as expected, that you are able to reproduce my scenarios in your computer. I'm using Go 1.22 for this content, so please take that in mind and use 1.22 or newer. If you have some experience writing Go, feel free to ask about what happens and why am I doing the things that I do in this way. And if you are a little bit more advanced and you have a lot of experience writing Go, probably this video is not meant for you, but I will do some references to best practices. All of you make the comments that you wish and start discussions about any of the topics that are covered in this video or that are somehow related with it. The application that I'm going to write for this video is going to be a program, a backend, that is going to store nodes. It's going to store nodes for a node-taking app in a way that it holds some metadata for each of the nodes. It's going to be very simple, but I think it's still a realistic case for a program. We're going to start by creating a Hello World project. And we do so by creating a directory, which we are going to call go-intro, and then changing to that directory. So now that we're in this new directory, go-intro, we initialize the module. That is required to keep track of the dependencies, and we do that by using this command line. Go mod for module, init for initializing, and then you have to use something that is distinctive there. Something that preferably you own, like in this case, github.com, my username, and then go-intro. So now that I have done this, I have initialized the project, and I can go and open the code for this project. So let's see that. And this is what we see when we open Visual Studio Code. We have here the directory we created, go-intro. This go mod is a file that contains the description of the module that we initialized when we did go mod init. And this is the version of Go that is being used. In this case, is 1.22.1. There are also some settings for Visual Studio Code, which are irrelevant in this case, and I'm going to create a new file that is going to be called main.go. In this file, I will put the whole program that we're going to create in this series. So what I'm going to do here is copy the program, and then we're going to discuss it step by step. Let me get rid of this part, and let's focus on the program. Every file in your Go code should belong to a package. Package is a way of organizing your code, and the main package is called main. So the first line in your Go file should be what is the name of the package that this file belongs to. So in this case, this file belongs to package main. Then let me ignore this for a second. We have this func keyword. That means let's start a function here. This is what I'm going to do, define the main function. And the main function, as in other languages, as in the C languages or C++, is the entry point for your code the whole code of your application. This is where your program will start running. And this parenthesis means that there are no arguments being used with this function, and this is the whole content of the function. Here, I have println, which is a function. If I leave the cursor here, it says that it formats using the default formats for these operands. What it does is just prints this with a new line at the end of this string. And this part here, the fmt dot, is that this function belongs to this package. And in order to be able to use it, we need to import it. And this is what we do in line 3. We import fmt in order to be able to use its println function. So that said, what we're going to do is to run this application. We're going to run it, and we are going to start by creating a launch.json file. This is only for Visual Studio Code. If you're doing this elsewhere, if you are a proper developer and you use Emacs or any other editor, you don't need that. This is only for the purpose of using Visual Studio Code and clicking here and running the application. So now that we have that, this is what it gets created by default. I'm not going to change it. I'm just going to close that file. And here I'm going to run this application. Clicking on the green arrow here. So here I have the debug console, and it should have printed this Hola Caracola, which is similar to Hello World, and is the output of our program. If you don't want to use this utility of Visual Studio Code and you prefer to do this by running the program from a terminal, you can go to the terminal and use go, then run, and then main.go for the file that we want to execute. So we enter, and it will print the same message to the standard output. That's it. The next step is going to be creating an HTTP server. Let me get rid of the terminal here. So one of the nicest things of Go is that it comes with all what is required in order to create an HTTP server in the standard library. In the past, if we wanted to deal with a URL, depending on the HTTP verb that was used, and by that I mean when you make a request, it is different if you make a post request than if you do a GET request or a PUT request. You could do that, but if you needed to do some work in order to process the request and extract the verb. Go 1.22 has added the capability to deal with those automatically. You just have to declare what you want to do, and it is backwards compatible. So in the past, we would have used something like Chi or even Gorilla Max if you have some H doing Go. But in this case, we're just going to use the standard library. First thing that we're going to do is to declare the IP address and port that will be used in order to listen to connections. In this case, it's going to be the local host, and the port number is going to be 8081. And the thing that we're going to do in order to listen to this request is going to be a declaration of an HTTP handler, adding it to the default MOOCs. The default MOOCs is basically the basic instructions for routing requests in the HTTP server. So what we're going to do here is declare this handle function, and let me get rid of the extra content here. And as you can see here, I am going to save, and it adds to my imports net/HTTP. That is the name of this module, HTTP, that is used to take care of all that is needed in order to use the HTTP server that is included in the standard library. Here, if I'm using a Go 1.22, I use the verb, the HTTP verb that I'm expecting, and this here is the URL that I want to be listening to. So The second argument for this function here is the function that will deal with this request. In this case, this is an anonymous function, lambda, and this anonymous function must receive an HTTP response writer. That is what you are going to use in order to send your reply, and the HTTP request, that is the information that has been processed and passed on to you from the HTTP server. Once I have declared this with this anonymous function, what I'm going to do is tell it what I want my answer to be. And in this case, it's going to write to this response writer. Let me remind you that W is our response writer. And I use w.write and this string here. Instead of hola caracola, I'm going to use HTTP caracola, just to notice the difference. This here is the conversion from a string into an array of bytes. That's a casting that I'm doing here because the write requires an array of bytes rather than a regular string. And that's all I need to do to describe a handler. Obviously, I can make it far more complex, but this is like the basic handler that you can write. The next thing that is needed in order to have the HTTP server is to listen. And we will be using the server address that we define as a constant at the beginning. And here is to define what is going to be the router, that the HTTP handle that is taking care of all the connections. In this case, because I say nil, is going to use the default one. That is the one that has been configured using this function. This function will run and start listening on this port. And in case any error happens, it will return an error. So instead of just leaving the function like that, what I'm going to do is to take this function and replace it. I'm going to attend to the error here, and I'm going to log the error if it happens. So I'm taking the output of this function, of the HTTP listen and serve, and whatever the error is, I'm going to log it. And I will log it as fatal because it has stopped my HTTP server from running. It might be considered a fatal error. It's not always the case, but for now, we will use it as such. Now that we have this, we can compile and run. So let's do this using our play button, as we did before. And once we have this changing color, we can come back to the terminal. And here, I could use go run main go, but I'm using the play button. And what I'm going to do is use curl. Curl is a command line utility, in case you don't know it, that allows you to send custom HTTP requests. In this case, I'm sending an HTTP request to the root URL. The local host is 127.0.0.1, the address that I use as a constant in the program. And this -i means that it will print the headers for the response. So I'm going to enter this, and it says, hey, I got an OK from the HTTP server. This is the header information. Basically, it's telling me the time, the number of characters in the header, and the format for the response. And this is the message that I was expecting because this is what I put in my HTTP handler. Cool. By the way, if you want to stop your program from running, you have to go to the red square up here and click on it. And it should stop your program. Finally, we would like to see what happens when we exchange some data from the HTTP client, which could be a browser, but in this case it's not, and the HTTP server that we are running from our Go program. The thing that we're going to do is to close the terminal, come back to our code, and we are going to declare, here we were using an anonymous function to define the handler, but it is far more maintainable to create a function that does that. So this is not going to be anonymous anymore. I'm going to create a new handler function that is going to contain what I want it to happen when I create a node. Let me remind you that the purpose of this program is to deal with nodes, and we are going to create a node by invoking this handler. Same thing, we're taking an HTTP response writer and an HTTP request, and we will be getting the information from the request and then writing our response to the response writer. That's it. So in order to exchange data, you have to know what is the format of the data that you want to exchange, and we're going to do this here. We're going to declare a struct that is going to contain the data that our nodes are going to have. In this case, a node is going to be a struct. This is how you declare a struct in Go. You say type, the name of the struct, and then the fields. The reason why node, title, and text, they all start with capital letters is because I want them to be readable, that I want it to be exported to the functions. So that is similar to using a public or a pub attribute for a field or for a struct in other languages. So here I have this node and it has two fields. One is the title of the node, the other one is the text. And what I'm going to do is make it a little bit more complicated and replace this node with something that is far more complicated. Now, a little bit. This node is similar to what we had before. It still has a title, which is a string, still has a text, which is a string, but it has two more fields. The first one is a series of tags. It may be empty, may have no tags, or it might have more than one tag. It's a string, it's a multi-valued field. And the other one is a scope. The scope has been declaring this other struct here, and this struct is saying this scope struct contains a project, which is also string, and an area, which is also string. So when I declare a node, I expect to have a project and an area, but they belong to the same embedded structure. Okay, so that sounds like some organization of the data, and this is what I'm planning to use here to exchange data. Let me go back to the handler that I have declared, and here I'm going to declare a function that will contain the node once it has been exchanged. The goal is to send a node from the request to the server and then use this server as if it was declared as a Go object. So what I'm planning to do here is to use the ability that is provided by the standard library also to deserialize information. And the data is going to be exchanged, as it is in many HTTP requests, as JSON. So what I'm going to do is to use this capability to decode JSON in our code. So here I create a new decoder that will use the body. The R is for the request, and the dot body is the part of the request that corresponds to the body of the request. When you exchange some data between the HTTP client and the HTTP server, there are headers, but there is a body. The body is usually where you put the data. And here it is complaining because I haven't imported JSON yet, so I'm going to do that right away. And if we go up here, you will see that now we have encoded /JSON. And JSON is not in red anymore. The reason why we get node and decoder in red is because we have declared both, but we are not using it. And Go is a very picky language in those terms. It wants you to declare things that you use only. So now that we have declared the encoder and created it, we are going to use it. And it won't complain anymore about those things, about not using node or the decoder. Because what I'm going to do is use the decoder to decode, and it's going to read the data from the body, and it will store the data, it will deserialize the data into this node instance that I created up here. This ampersand is a reference to the node that I'm going to use that one, and you can change the values in that one. I don't want you to copy the value. I want you to use this placeholder to put the data that you extract from the serialized data. This error here is going to tell me if anything went wrong. If all went well, it will be a nil. But if I got any error, it will have a value and I will have to act on that. So let's replace this. I'm going to copy it down and remove the first one here. So as you can see, this and this are exactly the same. What I'm doing now is I'm using the error that I got. I use a semicolon and then I do the comparison, checking if error was nil. If it was not nil, which means there was an error, then I want something to happen. And what is that? Well, what I want to happen is that I will use an error, and this HTTP error is also a function that is provided by the standard library, and I will write this error to the response writer, and the value of the error will be whatever was returned from this decode, and the HTTP status will be bad request, because I couldn't deserialize whatever was passed to me from the HTTP client. Once I've done that, I return because there's nothing more for me to do here. But if everything went well and I didn't get an error when decoding the data, then I'm going to do something different. I'm going to use FMT again, the same package that I was using to print Hola Caracola. And here I'm going to use another function. This F at the beginning means that I'm going to use a writer, and this writer is going to be the same response writer I was using before. And this is the format string, similar to C, but a little bit more robust, and it allows me to print the values of the entities that I have here. And this plus is to use the names of each of the attributes of this instance preceding the values. So let me summarize. I have this handler that takes a writer to write the response, a reader, a request that contains the data that has been passed from the client. Then I define a node. I create a decoder that is using the body from the request, and then I decode the data into that node. If there is an error, then I print the error, and I set the status to explain that there was an error here. But if there was no error, then I will print to the HTTP handler, so as a response to the HTTP client, the value that was sent onto me. And now that I have this, I'm going to use this handle, and I'm going to do it, declaring it before I start listening and serve. And that is going to be here, and I do it exactly the same as I was doing before. So I use the same format, HTTP handle func, but in this string, I'm using a different URL. So the URL is going to be /nodes, and the HTTP verb is going to be post. It's not going to be a get anymore. Then the handle function is not going to be anonymous, but it's going to be this function that I have declared down here. And that should be it. We should be ready to run it. So let's do that. We are going to run this, click on the green button here, and it should be running. Now we open the terminal here, and we could run this with go run Mingo if you're not using Visual Studio Code capability to do that. So, but what we're going to do here is to send data to the URL. Initially, we're going to send empty data. So what I'm saying here is use curl as the HTTP client, print the headers. The X is for the HTTP verb. In this case, it's going to be post. And if I don't use post, it won't go to that handler that I created. And the address is going to be the same one I was using before. And the URL is nodes, like the endpoint rather, is going to be /nodes. And if I do that, notice that there is no data. So when I enter this, I get a bad request because there was no data. There was nothing that could be decoded. And I get an end of file here. But if I create a different request, in this case, I put some data in, and the -d is to express the data that I have here. And this is the encoded JSON that I want to send to the other side. So I have a title, which is master plan. Then I have some tags. This is an array of a couple of things. Then the text of the node that I'm using and the scope that was the embedded object that I was using here. Inside of this embedded object, I have each of the fields that I declare. So the project is going to be wall domination and the area is going to be strategy. The URL, same one. So we run this, and in the response, we get this printed, which is exactly the representation, now not as a JSON representation, but rather the printed version of the Go structure that was used for deserializing the data. So fully a success. We stop the code, and that's it for this session. In this video, we have learned how to write a basic HTTP server from scratch using the standard library only. We have also learned how to add endpoints to that HTTP server and how to reply in different ways depending on the HTTP verb that is used. Also, we learned how to deserialize data that is sent through the request so we can use it in the backend. In the next episode, we will be using this data that has been deserialized in order to persist it in MongoDB Atlas. So, stay curious, hack your code, and see you next time.